Hello, everyone. My name is Dr. Peter Akonlabi, Assistant Cooperative Extension Specialist with the University of California, Division of Agriculture and Natural Resources, and also with the Biological and Agricultural Engineering Department at University of California, Davis. In this video, I'm going to begin a series of tutorials focusing on the spray evaluation section of the CitrusSprayEx system. Here is the application. I run it from my desktop. In another video, I have provided an overview of this application. It's basically a Windows-based application which was developed to provide decision support to growers and spray applicators who use air assist sprayers such as an air blast sprayer to apply spray to citrus canopies. The GUI, which is a graphical user interface, is sectioned into two. We have the spray planning aspect, which I've provided an overview of previously in another video, and the spray evaluation part. And we would be focusing on the spray evaluation section. This basically receives user inputs of application parameters, tree characteristics, orchard condition, weather parameters, and other parameters which are actually derived parameters from the user inputs to simulate spray application in citrus, and estimates as outputs percent canopy deposition, percent ground deposition or ground fallout here, and also percent spray drift, which is basically potential spray drift. So as a quick overview here, the application parameters consist of the sprayer make, air outlet width and length, which are the dimensions of the air outlet. We have airflow rate, we have nozzle type, and then the upper nozzle and lower nozzle, which is the spray delivered is divided into an upper section targeting the upper section of the canopy, and then a lower section targeting the lower section of the canopy. And then we have the number of nozzles for the upper and lower nozzles. We have operating pressure, we have ground speed, and then for tree characteristics, we have a mean tree or row height, we have skirt height from the ground, we have canopy diameter, and a foliage density. These are all parameters that can be easily obtained by the user. And for orchard condition, we have number of trees per row, number of rows, tree spacing, row spacing, and number of missing trees, if there are any. And then weather parameters, we focus basically on three parameters: temperature, relative humidity, and wind speed. And then these other parameters, as I mentioned earlier on, are derived from the other inputs, meaning that these are not actually input by the user, but they are derived based on the inputs that are made. So by clicking simulate, the system will run, will simulate a spray deposition model and use that simulation to predict the canopy deposition, ground fallout, and percent spray rate. And then we have this what if analysis, which would basically provide an information about the effect of changing a parameter from a previous run to another run. And we are going to make use of the information that is provided here. Before we move on, we are going to basically work with a scenario And in this first video in the series, I would introduce a scenario. In subsequent videos, we would be making changes to some of the inputs and then looking at what the effect would be based on what is changed. So let's go to the scenario. Okay. So here is the scenario. It says you are planning to apply pesticide to a citrus orchard using a conventional airblast sprayer. The recommendation says apply spray at 100 gallons per acre. This is our starting application rate. And you plan to travel at least 2 miles per hour ground speed. The sprayer has 10 nozzles per side, but based on tree height, you'll be using 8 nozzles per side. And we have 4 nozzles to the top, which is for D445. These are disc core nozzles. And 4 nozzles for the lower section, which are D523 nozzles. And the sprayer will be operated at 147 psi operating pressure. Now we are to assume an airflow rate of 42,000 CFM, and the orchard has 20 feet row spacing and 15 feet tree spacing within each row. There are 50 tree rows, each with 60 trees per row, and there are no missing trees. Now the trees are about 14 feet tall with 13 feet canopy diameter, medium foliage, and also 1 foot skirt height. The weather conditions at the intended application time are as follows. We have temperature at 90 degrees Fahrenheit. We have relative humidity, which is 95%, and wind speed, which is 9 miles per hour. So this set of information is what we're going to use to input into the system to run our simulation. So let's look at what we have. First and foremost, I would also want to point out that we are going to use English units. We can choose between metric units or English units. And for this particular purpose, we are working with the English units. And let's go through the inputs. By default, we have just one sprayer, conventional sprayer. There is no particular sprayer make, so that is left as default. The air outlet width, we're going to maintain the default. So the default is 0.4 feet, and we have 4.8 feet, which is the air outlet length. So it's the dimension of the air outlet. Airflow rate, we are given in the scenario 42,000. So let's change this to 42,000 CFM. And also for this application, currently we only have disc core nozzles, and so we can we select disc core nozzles, and then we choose the upper nozzles. We are given upper nozzles, 4 upper nozzles of D445. So we choose D445, and this is supposed to be 4 nozzles, and the lower nozzles to we have D523. So we look for D523, and there are also 4 nozzles. Number of open nozzles, we have 4 and 4, that is 8. So 8 nozzles, 8 open nozzles per side. Operating pressure, we are provided operating pressure of 147. So let's change this to 147 PSI. And ground speed, we are provided 2 miles per hour. That is our starting ground speed of 2 miles per hour. Tree height is 14 feet. Sketch height is 1 foot. Canopy diameter, we are provided that as 13. So let's correct that to 13 feet. And the canopy foliage density is medium. That is our starting foliage density, medium. The number of trees per row, we have 60 trees per row. Number of rows, we have 50 rows. Now, tree spacing is 15 feet. So that is tree spacing within the row, 15 feet. And then row spacing is 20 feet. There are no missing trees, so we keep that at 0. And then for the weather conditions, we have 90 degree F. We have 95%. And then we have 9 miles per hour. This is fairly high, but within the acceptable wind speed. So we have entered all the inputs that we are provided, and we click simulate, and the simulation process goes through, and at the end we would be given estimates of the canopy deposition, ground fallout, and spray drift. So let's wait for the simulation to be over. And there we go. So we targeted 100 gallons per acre, and the output here tells us this is a derived parameter, application rate, which is 100 gallons per acre based on the inputs we had. Now, canopy deposition is 57%. Ground fallout is 17%, and spray drift is 26%. Now, these are percentages, and we'll see as we go on through the various changes, we'll see that these will change based on the composite of parameters that are used. Now, to make any clear, to derive a clear relevance of these values, we can look at the percentage in the value in terms of actual gallons per acre, and we are provided as a start 100 gallons per acre application rate. So this means that out of that 100 gallons per acre, 57% is estimated to deposit on the canopy, which the canopy deposition is actually our desired application output. So we end up with 17%, which in this case equates to 17 gallons per acre just going to the ground. And then we have 26%, in this case is 26 gallons per acre going to the ground. That is our first simulation, and in the next videos, I will talk about making different changes starting off from this point. Thank you very much.